I hope everyone can hear me okay. Welcome to ChainSafe's inaugural virtual event. My name is Dustin Brickwood. I will be your MC for today. Can I get some excitement in the chat, please? Awesome. Thank you very much. Woo! I'm excited to be here. I'm excited for our speaker lineup today. And we at ChainSafe are even more excited to connect with our community for our first virtual event. Before we get started with our awesome lineup for the day, we realize that some of you, it may be your first time on Remo, which is the software, virtual conferencing software we're using today and for the next 3 days. So I want to kind of address a few key items to get you familiarized with the software and its features. So first, you'll notice that some of us have pictures within our circles. That's because we've updated our profile. I encourage everyone to add their picture, maybe their LinkedIn account, and a little headline to kind of showcase who you are or where you work. If you notice when you first jumped into the software, you were assigned to a table. That's how Remo works. You're randomly assigned to a table when you first enter a room. To join a conversation in video, you simply double click on your table and you will pop into what looks like a standard video group call. So just be sure to turn on your camera and microphone, and you can do so by using the controls at the bottom of your screen. You can move around any table with an open seat by double clicking on an empty seat at the table. The people already seated at that table will hear a knock knock noise to let them know that someone new is joining the conversation. You'll only be able to see and hear the people who are seated at your table, which is awesome. So it gets the feel of what you're actually at a virtual conference, or at a real conference, I should say. So now at this point, when you are in conversation at a table, you can look at the bottom toolbar and there'll be a tile view. This will allow you to see all people at the table in a very similar viewpoint that of Zoom. If you want to go back to the floor, just select that and that'll bring you back to the floor. So I encourage you to move around, mingle, converse with others, and connect. In the menu bottom of again at the bottom of your screen, you'll also find a chat button. You'll be able to chat with individuals at the particular table as well as the general chat. So if you do want to connect with someone in particular, you can reach out via the chat features. If there's any technical issues, Paulina will be able to answer any kind of general questions. Paulina just said hi in the chat, which is awesome. And if you are a speaker and you're having technical difficulties or you have questions related to how the presentation may go, Ryan will be able to answer any general questions. Well, in presentation mode, which we're on right now, you'll see that everyone gets pushed to the main stage. So right now, only I am able to share my video and talk. When it's your time to speak, I will elevate you to kind of speaker permissions, and you'll be able to join me on the main stage. If you just want to connect and network with people, we have set up a dedicated networking lobby, similar to what you saw when you first entered the event, which is just the table view. You can hang out there and not be dragged into presentation mode if you choose. You can do so by clicking the link in the middle of the conferencing room that you may or may not have seen. So we have talks running all day today from 10 a.m. Eastern to 5 p.m. Eastern, which is awesome. We have 7 different companies talking today, which is just amazing. So feel free to pop in and out throughout the day. Presentations are going to be running. If presentations end early than the kind of 30 minutes allotted, we will move back into the floor view until the following presenter is ready to present. Now, I know the moving back and forth may be a little bit cumbersome, but please bear with us. This is a virtual event, so there's definitely going to be some friction. Other than that, without further ado, it is my absolute pleasure and excitement to introduce our first speaker today. He is our CEO, Aidan Hyman. Aiden, why don't you join me on the main stage here and turn your camera and mic on? It will take a second, so I apologize. Hey, Aiden, how are you doing today?
Dustin, I'm doing well, thanks.
Awesome.
For joining us today.
The floor is yours.
Thanks, Dustin. All right. Perfect. First of all, I just wanted to welcome everyone to our inaugural. It is something that we are really proud to be putting on, and even more proud to be able to share this stage with so many of our incredible partner projects and really just people in the ecosystem that we're truly honored to be working towards their visions. So firstly, again, thank you to everyone who's attending today. Thank you to the speakers for taking time out of your lives to make this the event that it is. And a real big shout out to the ChainSafe Party Planning Committee. That includes Dustin, of course, Cindy, Paulina, Ryan, and Stu for making everything you see today here possible. Just gonna go to the chat part just to make sure if anything bad happens that you all can let me know. So firstly, why did we do this? Well, at ChainSafe, it's really important for us to get across how important collaboration has been for our organization and in the projects that we work on in delivering exceptional projects. You know, we really do believe that collaboration is good for the whole garden. When building an ecosystem of projects that all work together, it is vitally important that there is synergy amongst these different organizations so that you can work towards what is a common goal at the end of the day that is shared across these different organizations. So we hope that this is an event that can really bridge a lot of those gaps that don't necessarily get kind of bridged often enough. You know, we have so many different exciting ecosystems that we contribute to that we feel are really secluded from one another and don't get opportunities to collaborate and have these open conversations and just to learn from one another, because at the end of the day, everyone is really dealing with a lot of these similar issues. So just to briefly discuss a little bit about ChainSafe, a little bit about how we're broken down, and then I'll get a bit into you know, one of the projects that we're working on in detail, while also highlighting some of the incredible work that everyone at ChainSafe is doing every day. So really simply, our mission is to realize the potential of Web3 through sustainable open source development. And we'll talk a little bit during this talk about what open source means and what sustainability means for us as an organization and generally in our ecosystem. And very simply, we envision a world with organizations that empower people to create and innovate. Too much of the organizations that are sitting within, you know, the modern tech stack are really just there to take advantage of asymmetrical power dynamics that really favor the incumbents and don't allow for newer, innovative projects to take shape in an innovative way. So just a little bit about, you know, how we've gotten here. We're almost a 4-year-old company where a lot of us met at the Ethereum developers meetup here in Toronto. Our founders then kind of started to realize that we really do want to work together regularly on bringing this technology to the forefront of the world. And so we started moving, and it all goes kind of to the right. We started to rent some space at our local public library. And from there, we started to need a real office. So we started moving into the living room of one of my co-founders, Stu. And after that, we were really fortunate to be offered some space in the office of a project that we were contributing towards. And, you know, without that, these community events like the Ethereum developers meetup, like that project who offered us real office space, we wouldn't have had the ability to not just meet each other, but to work towards what we see today. And so we're incredibly thankful and feel that, you know, it is our duty as a result to contribute towards the things that gave us what we have today. In the middle, you'll see at the bottom that is our first office, which is now the office next to our current office, which you see on the right, and is currently just, you know, a room of couches where we can hang out and relax. And on the bottom right, you can see what is one of the last meetups we had a few years ago, which is the Ethereum developers meetup that we now help co-organize out of our office. And this is one of the last times, unfortunately, it's kind of bittersweet that we got to be with a large number of us together. It's at the last ETH Waterloo, and outside of the people that regularly come to the office or did come to the office, this was one of the last times we were able to see people that don't live in Toronto. Obviously, with COVID, there's been a lot of differences in the way that, you know, we interact physically with one another. And so we definitely are thankful for having had that opportunity to have been with each other. And so where are we now? Well, now ChainSafe is a company that's distributed across 15 countries, with a few more by the end of the year to be added to this map, with over 40 members. So, you know, within the early parts of the new year, we'll be at over 45 people. So how do we kind of do what we do? Well, really simply, we're broken down into a few different departments that work together while working, you know, in very specific roles. We have our engineering, our project management, operations, and business development departments, which all work towards our common goal of Web3 adoption. And how does our business really function? Because so many times people ask us, you know, how do you do what you do? Or, you know, how does it kind of maintain its sustainability? And that's through these three kind of different functions, which is a consulting, R&D, and product wing. And these all work really closely together while also all working towards Web3 adoption. And so obviously in not every situation are there double-sided arrows going to each and every one, but this is just to articulate how each and every one of these functions can work together and all can gain momentum from Web3 adoption while contributing to Web3 adoption. So it's really important when we are kind of describing our business to articulate how each and every one of these pieces work together towards what is our goal at the end of the day, which is Web3 adoption. And so how does a general team look at ChainSafe? Well, we're made up of a group of engineers with a tech lead and a PM. And these people work together towards executing on the projects that you see here. Lodestar, which is a TypeScript implementation of the ETH2 ecosystem. Gossamer, a Golang implementation of the Polkadot host. Ethermint, which is Ethereum on Tendermint using the Cosmos SDK. Forest, a Rust implementation of Filecoin. And ETC support into Hyperledger Besu. All of these projects will be discussed over the next 3 days, and you can learn from the people who are making these things happen. And if you're ever interested in seeing kind of what that looks like on a day-to-day basis, you can always follow our code on GitHub, which is something we're incredibly proud of. A whole bunch of other projects that we're working on as part of those different protocols, as well as for general purposes, includes Chainbridge, which I'll discuss a bit more in detail in the next few slides, which is a modular multi-chain blockchain bridge. Web3.js, which is the Ethereum JavaScript API. Anemone, which is a testing tool for batch transactions and opcodes. Gossip Sub, JS Gossip Sub. BLS, SHA-256 and assembly script, Go Snorkel, and ChainDB. And a bunch of these projects to the bottom are all really the core that make up what the previous protocol projects are. And so, these and many other repositories are all available within our GitHub. So I definitely suggest that you check them out if you're interested in any of them and want to see what else we're working on that I couldn't include in this one slide. And so one of the core things at ChainSafe is our protocol objectivity. And what's incredibly important here is to remember why it is all of us are here and build in the technology that we're building. And really simply put, we're here to disintermediate a digital world that currently asymmetrically holds certain incumbent players in a position of power against those that they are just extracting value from. And we truly believe that if blockchains do aim to disintermediate this asymmetrical power dynamic that is truly prevalent in society, not just in the digital world, how are we able to do this if one blockchain is the intermediary for that disintermediation? And that was something that always felt hypocritical to us and always felt like it was completely in contrast to what the true ethos of this movement is, which is to empower individuals to build the things they want to see in the world. So also, to go back and discuss a few of the things within our mission and vision, which is sustainability. Very simply, sustainability is the ability to exist constantly. And this is really important because existing constantly ensures that our software will be able to be relied on and be able to provide high value impact consistently and without any doubt. To us, open source is very simply can be taken from the Linux Foundation's website on what is open source, and it can be anything that meets this criteria of, is it available in its source code? May that source code be modified and redistributed? And finally, does it have any other criteria? So it is really important to understand what we mean when we say sustainability, what we mean when we say open source, and then what that open source looks like sustainably in the traditional world. And so currently looking at the Linux Foundation's Platinum sponsors, you see a whole bunch of different companies here. And all of these companies, you see them and you see that they don't necessarily have their own vertical. Rather, they're competitors with each other and are all looking to basically out-compete one another in the markets with users on a day-to-day basis. And so what can we learn from that? Well, we can learn that simply if we're not able to get competitors to see value beyond zero-sum thinking, we will lose and our technology will never gain traction. And that is an incredibly important takeaway because there is no ability for us to have this consolidation of a single platform, because without having a multitude of options for people to use like you do in the open source world, people cannot and will not see value beyond zero-sum thinking. And so that protocol objectivity, that sustainability, and that open source model must align with the different businesses and companies that are looking to utilize that technology. We cannot be building in isolation. And so a response to that project is Chainbridge, which is currently being supported in 8+ projects and was originally supported by ETC Labs, Centrifuge, Celo, and Aragon. And you'll learn more about a few other projects that are integrating Chainbridge into their stack. And what is incredible about this project, as it aims to eventually allow for a single relayer set to facilitate cross-chain data exchanges in a way that does not rely on a single blockchain. So what are our goals for this project? In that it can be easily integratable to any future chains, that the ability to transfer between multiple chains should be a top priority, and that there's a modular security aspect where you do not need to utilize a specific security model and can actually implement any type that you choose or utilize any of the options that are available. And so what is a final takeaway here when kind of looking at the talk as a whole and really summarizing it is that, without learning the history of open source, it is easy to think that good intention is what has fueled this movement, when in reality, the fuel for this movement is economic cooperation. That should be an obvious thing to people building within the blockchain space, but it's sometimes not necessarily understood at the protocol layer, that without different actors that could be competitors working together towards some commonality, without the need for zero-sum thinking, open source cannot succeed. And at the end of the day, blockchain technology is an accumulation of a whole bunch of movements, but at its core, the open source movement is what is the kind of core anchor to the things that we build. So that brings us back to this slide, which is that collaboration is good for the whole garden. If we are not working together towards some commonality, towards some common goals of general Web3 adoption, and are not able to work together and are stuck fighting with one another, while not too many people outside of the blockchain space are using blockchain technologies, how can we expect to ever get to mainstream adoption, right? It is the conversations that we have with people that don't necessarily hold the same technological biases that we have going into those conversations that will be able to change our perspective and help us learn the most. So unfortunately, this slide isn't the biggest, but this is the schedule for today. And I'm just so incredibly excited by the amazing speakers that are participating today, tomorrow, and on the 4th. We're so proud to be able to have all of these different people that we either work with or work towards some kind of common goal. And it's something that has taken us, over 3 years to get to this point where we can have so much to share with not just our community, but hopefully the communities of all of these different projects. And if you're wanting to look at the schedule and see what's available over these next 3 days, please go to cscon.chainsafe.io, where you can also see our incredible new website that Cindy has been working on, and just learn a lot more about us, our values, and what we're looking to really do with this technology. Some more schedule. And then, of course, the final plug is that we're hiring. We're currently looking for the following positions, and you can check it out, the actual job descriptions at chainsafe.io/careers. Thank you so much for joining us today and for joining us hopefully across these next 3 days. There's my email contact, our Twitter, where you can follow a lot of the conversations, our GitHub, of course, and our website if you want to learn more about us. Thank you so much, everyone.
Thank you so much, Aiden. That's awesome. I always love hearing ChainSafe's origin story. That's great.
Thank you, Dustin, for making this happen.
We do have a couple Q&A questions for you. The first question is, what were some of the early challenges starting ChainSafe?
Yeah, it's a really good question. Saying you're focused on protocol objectivity when really all we were working on at the time is Ethereum, it definitely was a challenge in conveying that vision. But we always felt from day one that, to restrict ourselves to one platform is restricting our ability to truly impact a wide spread of different ecosystems.
That's awesome. We have one more question in Q&A. Why start off as a consulting business and not a product or ecosystem at the beginning?
Yeah, that's a really good question. For us, it was very clear from the beginning that the most impact we can have is by working with others towards realizing their visions, and at the same time taking those lessons learned and realizing what is truly necessary for blockchain adoption. So for example, if we go back to, let's see if I can quickly go there. If we go back to this slide, right, there's so many different ways in which Web3 adoption and different aspects of our business have affected both the products and R&D side of things. So I would say that working with communities, understanding what they're truly looking for, and then being there for when Web3 adoption does occur is truly the biggest privilege we've had is by having a pulse on what is going on and what people are looking for from this technology.
That's awesome. Well said, Aiden. That is fantastic. So if you can join me in doing some emojis and clapping emojis in the chat for our CEO, Aiden, that'd be awesome. Aiden, thank you so much for kicking off CSCON. It's absolutely been a pleasure. Thank you, Andrew. Absolutely. So right now,
thank you, and I'm excited for our next talk.
Absolutely. So right now, if you don't mind killing your screen share and heading off the main stage, I'll introduce our next speaker, someone who is one of the earlier ChainSafe employees, the absolutely amazing Elizabeth Binks, who will be presenting Gossamer, a Polkadot journey in Go. Elizabeth, why don't you go ahead and turn on your camera and microphone and join me on the main stage. Hey, Elizabeth, how you doing today?
Good. How are you, Dustin?
I'm doing well. We have a great audience here today, so I'll leave it to you and enjoy.
Cool. Sounds good. Okay. One second. Okay. Cool. Okay, looks like you guys can see my window. Alrighty. Okay. So, hello everyone. So, today I am going to be talking to you about Gossamer. So, yeah, I'll just get right into it. Okay. So, yeah, hi. I'll introduce myself to start off. So I'm Elizabeth. I'm a software engineer and tech lead at ChainSafe. So I'm the tech lead on the Gossamer project. I've been working at ChainSafe for almost 3 years now. In March, it'll be 3 years. Yeah, and these are a few of the projects I've worked on in my time. Cool. So I'm going to give a quick intro about Polkadot. So first of all, what is Polkadot and why did we choose Polkadot? So Polkadot is an interoperability protocol, first of all. So its main goals are to have interoperability and shared security between various chains that execute different state transitions. So as you can kind of see in this diagram, this is sort of a high-level picture of the system. So we have the relay chain in the middle and then the pair chains on the sides. Yeah, so another goal of Polkadot is to have forkless upgrades, so to be able to update the runtime of the chain without needing to fork or upgrade your node. So this is in contrast to Ethereum or some other networks where you have to fork the network to upgrade. And if you would like more information on Polkadot, you can see the Polkadot light paper in their documentation. It's a good overview of everything. Cool. So a little bit about Gossamer. So we got a grant from the Web3 Foundation last January in 2019 to build the Polkadot runtime environment in Go, as it was called at the time. So Polkadot runtime environment has since been renamed to the Polkadot host. They are the same thing, just renamed. Yeah, so ever since then, I've been working on Gossamer, which is the Polkadot host implementation in Go. So you're probably asking, what's the Polkadot host? So that's a good question. So you've probably heard of Substrate. So Substrate is the original implementation of a Polkadot host. So the idea with the Polkadot host is that it's a blockchain framework for building your own blockchain. And in addition to that, it's compatible with the Polkadot network. So Substrate is the framework, and then Polkadot is the actual protocol that the network runs. And Substrate has also been used to build other Polkadot networks like Gossamer and the testnets. So Gossamer provides the same functionality as Substrate, or ideally it will very soon, but except it's implemented in Go instead of Rust. So yeah, and if you would like more information on Substrate, there's a really good talk by Gavin Wood at the Web3 Summit 2018 called Substrate, a Rustic Vision for Polkadot. So I'd recommend watching that. Cool, so I'm just gonna give a Gossamer update. So our primary goal for Gossamer at this point is interoperability with Gossamer and Polkadot. So we're getting very close in terms of compatibility. So we've recently upgraded to the v0.8 runtime. I'll explain a little bit more what this means in the following slides, but essentially it means that the API for the runtime matches now with other networks. And then our in parallel goal to that is to have Polkadot.js support for Gossamer. So this would allow users to easily interact with the node, manage their accounts, and submit extrinsics, and to monitor the network in general. And then we're also working on updating, also related to interoperability, is updating the networking protocols that we can sync with Gossamer and Polkadot, because it's recently been upgraded. And then as well as just internally testing the Gossamer nodes so that they can stay synced and continue to finalize under various conditions. Cool. So so a runtime. So one of the most interesting and challenging parts, I would say, of Gossamer is the runtime. So the runtime is the state transition logic of the chain. So as you can kind of see from this little picture, the block represents one transition, I suppose. Well, the transition is, so how a block is created is determined by the transition function, as well as what transactions are valid to be included in that block. Okay, so so the Polkadot host is essentially everything around the runtime that allows it to become a blockchain. So everything except the actual runtime itself is the host. So the things like networking, the storage tree, databases, all that kind of stuff. That's what the host is. All the things that are used by all blockchains. So what is the kind of design decision for building the host in this way? So like I said earlier, one of the reasons is so you can upgrade without forks. So this allows for on-chain governance, so you can submit votes to the network to upgrade the actual state transition of the chain itself. So the runtime is just a binary that's stored in the storage tree, so it can easily be changed at any time. And as well, the other design decision is to have a standard interface for the runtime so that people can easily implement their own custom chain. So like I said earlier, the WASM, so runtime is just a WebAssembly or WASM blob that's executed via some interpreter that's in the host. So it's sandboxed from the rest of the code. And then it doesn't store any node data. It just deals only with the state transition logic. It doesn't store anything like the storage, keys, anything else it needs. It gets that from the host, which I'll explain a little bit more in the following slides. So Gossamer currently has support for two different WASM interpreters. Gossamer, sorry, the slide isn't great, but Gossamer and Runtimes. So why? So these two perform the same functionality, which is interpreting WASM code. So currently it has support for both because we want to eventually benchmark the two of them, see which one's more efficient, as well as determining eventually which is more maintainable for us, which has an easier Go API to use. So yeah, so using Gossamer. So so if you would like to make your own Gossamer chain, what do you have to do? So the main thing is putting in your runtime. So if you look here in the Genesis file, there's a section of the Genesis file called system code. And this is where the runtime code at Genesis is stored. So when you launch your chain, it launches the chain with whatever code is stored in this system code key. So if you want to make your own custom chain, you need to have your own custom runtime, first of all. It has to be compiled to a WASM binary. And then once you've done that, you can simply throw it into this Genesis field system code and then hit run, and everything should work. Yeah, as long as the API matches. So what is this API I've been talking about? So from the Go side of things, the runtime consists of specific API functions. So the runtime needs to expose these functions so that the host can call into them. So this interface here that you see is the interface that Gossamer uses to interact with the runtime. So the functionality of the runtime is to do with block production as well as block and transaction validation. So, and then there's also a few functions for configurations that have some constants stored in them. So yeah, so the first 4 functions here are to do with, configuration options. And then the one after that, validate transaction, is for validating incoming transactions before you include it in a block. And then the next 4 functions from initialize block to finalize block are used to actually build a block. And then the last one, execute block, is used to verify a block that you've received from someone else. So at specific points in Gossamer's execution, it'll call into these functions whenever it needs. So yeah, that's essentially the API. So as long as the runtime matches these functions, or matches the API, exposes these functions, it is good to go. Cool. So what's kind of inside the runtime? So a runtime, you can build it either yourself in whatever language that can compile to WASM. You just have to implement the API that I showed in the previous slide. Or you could use Frame, framework for runtime aggregation of modularized entities. So this is a domain-specific language for building runtimes, also written by Parity, and it's written using Rust and can be compiled to WASM. So the runtime is, if you use Frame, is composed of modules called palettes that have specific functionality that you potentially would like in your chain. So a lot of them are just common sort of features that you would like in a chain. So like value transfers, like tokens, perhaps. There's also stuff to do with smart contracting, EVM support, and there's also stuff to do with consensus, so Babe and Grandpa, as well as on-chain governance. So you have staking, which is super, super important, as well as other governance things like I see treasury, elections, democracy, that kind of thing. So the idea with palettes is that it's easy to just plug these into your runtime, just like pick and choose what you need, as well as if you want to make your own custom palette, you can easily do that as well. Yeah, but then you wouldn't have to worry about the more basic things like value transfers. You can just plug those in. Cool. And then also, I don't know if you guys can really see from this picture, but there's a support library that easily turns the modules into the API. So cool. Okay, so what does Gossamer look like from the runtime? So while the runtime is executing, it's able to access certain Go functionality that it needs via some functions that are imported into the runtime instance. So the reason for this is because like I said earlier, the runtime is just a binary that just has the state transition logic. It doesn't have anything stored in it. So it has to access the storage tree, which is located in the host. So to do this, the functions that are imported into imported into the runtime instance can all access this context struct. So the context contains an interface for the storage, as well as allocator for managing memory, the key store for signing, and then a few other, the rest are mainly just constants for letting the runtime know what the state of the node is. So the storage is the main one that's used. So the runtime is essentially the only part of the host that modifies the storage tree. So while it's doing some either block building or syncing a block from someone else, it'll be updating the storage tree to update whatever values are needed, as well as get whatever values are needed, delete any values. So the runtime essentially does all the storage tree management for you. And then the storage tree is just a modified Merkle partition tree. Similar to Ethereum, so not exactly the same, but similar idea. Cool. Okay, so why is all of this interesting? So this makes the runtime really modular. So essentially, as long as the API stays the same, the runtime can change with as much as it wants without any changes to the node. So like I said earlier, this lets you have governance, upgrades without forking, that kind of thing. So so Gossamer runtime updates mostly consist of updating the host to work with a newer API. So generally, when the API changes, the core functionality stays the same. The main changes are maybe a few new functions or renamed functions or different parameters, like that kind of thing. As well as the imported Go functions might be potentially different. Cool. Okay. So what are kind of the next steps for Gossamer? So like I said earlier, one of them is Polka.js support to allow for easy user interactions. And then kind of alongside that, we'd like to build a Go extrinsics library to allow for extrinsics to easily be formed and submitted on the Go side, because right now all the tooling is in Rust or JavaScript. And then as well, since we have updated the runtime, we would like to try syncing with the different networks. So the main ones would be Polka and Gossamer, and then also just a local substrate node, just to make sure that everything works with that. So the main kind of blockers here are just the networking protocols. So stuff like message encoding, potential like the stream protocols, that kind of thing. And then another next step is to just run a Gossamer only testnet. This can kind of be done in parallel with the interoperability stuff. So this is kind of just to test that the functionality is consistent within Gossamer nodes. So to make sure that finality continues to work, the network doesn't fork, changes to the epochs and the authorities, the runtime and such are propagated correctly. And then as well to test under various network conditions, make sure all of that stuff still works. So at the Gossamer testnet stage, essentially users should be able to play around with the node, join the testnet hopefully. And then as well as at that point, they'd be able to try their own Gossamer chain. So if you have perhaps an existing runtime or you want to just make one, you can try to plug that into Gossamer and see what happens. Cool. Okay, so that's essentially it. So thanks for watching. If you would like to check out the code, you can check it out on the ChainSafe GitHub. We also have some docs up at gossamer.chainsafe.io. And you can also contact me if you'd like at my email, elizabeth@chainsafe.io, or you can also message in the Discord, which is in the Gossamer README. Cool. Okay, thank you. And then hiring slide, because we're hiring. Cool.
Awesome. Thank you so much, Elizabeth. I'm beyond excited for the future of Gossamer and the Polkadot ecosystem. Very exciting stuff. We do have a couple questions for you. And just to let everyone know, there is a Q&A section. Feel free to put your questions there, upvote on particular questions you want answered in priority, and so forth. So the top Q&A question for Elizabeth: what has been the hardest aspect of testing runtimes?
Great question. Okay, so I'd say the main thing is just the fact that the runtime is opaque. Like it's just a WASM binary. You don't really know like what's going on in it. So when you're executing the runtime, you can't really see what's going on internally. You can only see when it's calling into Go functions. That's like, but then between that, you don't know what's happening. So sometimes if you have like potentially wrong encoding or some wrong data, it's really hard to know like what is wrong about it and like how it's internally calculating and decoding it. Like sometimes you can try looking at the Rust code to see what it's doing, but like I said earlier, it's written with frame for the most part. So then there's a lot of like layers that sort of wrap it. So even when you're looking at the substrate code, it'll say like, oh, it calls like system whatever key it wants, and then but then when it gets compiled to WASM, that completely changes and it turns into various other operations. So it's hard to know exactly what it's doing. So it's mostly So I'd say the hardest aspect is just like getting the data to encode properly, getting it all to decode properly inside the WASM binary, that kind of thing.
Awesome. Thank you so much. Our next top question: does this mean I won't need to know Rust to work with substrate blockchains?
Correct. Yes. So you won't need to know Rust. So Gossamer, yes, pure Go. Everything's Go. So I guess the only Rust you would need to know, it's not even so much Rust, but just to build your own runtime, you would need to use something that would compile to WASM, which is frame so it would probably be frame, which is Rust-esque. So but you wouldn't need to know Rust to work with substrate blockchains.
Awesome. Thank you so much. Another question: what has been the most challenging aspect to building Gossamer?
Okay, another great question. So the runtime has been definitely one of the most challenging, just because, like I said, it's super opaque, as well as there aren't any pure Go WASM interpreters as far as I know. So sometimes you have to deal with some funny things happening. Mostly uses like CGO behind the scenes, as well just dealing with like a lot of spec changes. So at a higher level, just I don't know. Sometimes you'll implement something and the spec changes and you have to go re-implement it, and takes twice as long as you expect it to take, and that kind of thing. So mostly, technically probably the runtime, and then just in general, just spec changes, trying to keep up with substrate, that kind of thing.
Awesome. Our last question for you: why do we need a Go implementation of this?
Great question. So every sort of network needs multiple implementations of the protocol for many reasons, but the main one is just that if there's a vulnerability or some issue in one of the implementations, hopefully the other implementations won't also have that issue. So this has been demonstrated on Ethereum a few times. So just essentially having a more robust network with many implementations of the protocols.
Awesome. Yeah. Let's get a clapping emojis to Elizabeth. Elizabeth, thank you so much for your time and the great presentation.
Cool. Thank you so much.
Awesome. Go ahead and unshare your screen, and thank you so much.
Yeah, thank you, Dustin. Okay, bye, everyone. I'm not
So
sure how to-
it's okay. Just turn your camera off and mic.
Okay.
There you go. Awesome. So at this point, we're going to go back to the floor. Our next presentation will start in about 9 minutes. So tune back in.